Hi guys, welcome to another week of online learning. I want to start off this week on the web page again, just to show you where you should be going. So the first thing to note is if you're on a cell phone, you need to hit the three little lines in the corner that will drop down the course list. Now, some of you have been interested in continuing to learn the whole course and seeing my notes that are posted. So the course without the date behind it, Math 30-1, Science 10, Physics 20, these are the entire course that I had posted before all of this happened. So if you go in here, every single unit is in here with all of the notes that I have. That's not where I want you working for this online learning that we're doing right now. I want you to go to Math 30-1 2020, and this is going to be the list of videos that I'm putting together for this current situation. So keep in mind that a lot of topics are going to be omitted. So for example, in our next unit, I'm doing polynomials and rationals, and I'm completely omitting the radicals lessons. If you want to see the lessons that I've omitted, they're still up here in Math 30-1, but what we're working on for this point in time when we're cutting out certain outcomes is polynomials and rationals only. So click on the drop down arrow. If you click on Math 30-1 alone, it won't take you to the right place. You have to click the drop down menu and go to the unit. First thing assigned is it was brought to my attention that I skipped over 2.7. Oops. This is new for me too. I'm still figuring everything out. So I put together a video for 2.7, solving log equations. That's in there. There's also all of the answer keys now posted to everything, a review booklet, everything you would need to study this unit and know it well is posted on this section here. We are skipping over word problems, but you now have all of the skills that you need to solve word problems without graphing. If you recall, a few weeks ago, we learned how to solve word problems, and we had to do it by putting it in our graphing calculator. So we would enter a y1, y2, usually change our window to a ridiculous scale, and then we would find the intersection. Now you can actually solve word problems using the 7 rule, and you can do it algebraically, which most people find simpler and faster than graphing anyways. So you can do that if you'd like, but I won't be supplying a video for that. So step 1, do 2.7, watch the video, and then the textbook questions on the last page of the slides. 2.8 is something that we did last week. I didn't get too many questions on this. At this point in time, we're being asked to provide you with formative assessments. So everything I'm giving you here from the textbook and worksheets is formative. We don't have any guidance from head office or the government on how marks are going to work. So at this point, it's just me giving you feedback on how you're doing. So in order for me to do that, the best way is probably a video chat. Or email questions. We can work our way through that, but sometimes talking about math over email is quite difficult. So if you do have any questions on that, I know we kind of started with quite a complex lesson. Please don't hesitate to book a time with me to video chat, and we can go over some solutions together. The next lesson that we're going to cover this week, 2.7 is first, will be in polynomials and radicals. Or rationals, pardon me, and it's going to be lesson 3.1. So I'll teach that to you now. The worksheet is listed, the answer key is listed, and there's textbook questions as well. So here's 3.1. This unit, again, is about graphing polynomials, radicals, and rationals, but radicals we will omit for this remote learning time that we have. We're going to talk about characteristics that polynomial functions have, and most of this will be review. We studied polynomials in 10C and 20 and 30-2. We're just putting them all together in a big group now. So here's a whole bunch of different types of polynomials. You can have constant, linear, quadratic, cubic, quartic, quintic functions. They can be written as f of x equals or y equals. They can also be written for constant functions as x equals. So remember, a y equals 3 would be a horizontal line like this. X equals -2 would be a vertical line, so not a function for this one. Linear, we did this in Math 10C. These are mx plus b, so slope y-intercept equations. Any kind of straight line that slopes across the Cartesian plane would be a linear function, which is just a special word to describe a polynomial function. Over here we have degree. Now what this means is if you find the x in your equation, it's the biggest exponent that x has. So for this one, there is no x. That's degree 0. For this one, the secret exponent on x is a 1. For quadratics, the biggest exponent that the x's have in this equation is a 2. If it's in factored form, you would have to FOIL it out in order to see that. Quadratics we studied in 20. There's an example of a quadratic. They have things like a maximum or a minimum, an axis of symmetry. They open up or open down. We can study all sorts of characteristics about quadratics. New to the 30 level is cubic functions. So you can see they are degree 3. The biggest exponent on x is a 3. They are similar to linear in that they go diagonal across the Cartesian plane, but cubic will have kind of a little loop thing in the middle here, for lack of a better term. So they won't be perfectly straight. They'll have some kind of weird something or other happening in the middle here. Quartic, quintic, degree 4, degree 5. We don't need to go into too much detail here. All we need to know here is that a quartic, degree 4, does not go across, but it's more like a quadratic, how it goes kind of bottom to bottom or top to top quadrants. And then quintic, again, crosses. It just has more little loop-de-loop thingies in the middle than a cubic. Here are some definitions to know. Degree we looked at, highest power on a variable. So you need to find x. The biggest exponent on x is going to be your degree, and you're going to need to look at that in expanded form once it's all FOILed out. Leading coefficient. We must organize our terms in descending order. That means you start with the biggest x power and you go down to the smallest and then the constant at the end. Here's an example back here where I started with x to the 4, then x cubed, x squared. If there was an x, it'd be next, and then the constant. That's a descending order. Once it's written in descending order, the first coefficient is called your leading coefficient. We need to know that because they tell us something specific about direction of opening. The constant term, whatever number doesn't have a variable with it, if it's written in descending order, it's at the very end. Be careful with signs. For example, up here, x to the 5 minus 20, the constant is -20. X-intercepts, where does something cross the x-axis? In 20, we studied that these can also be called zeros, solutions, or roots when we studied quadratics. End behavior. Where does it start and where does it end? You need to know your quadrants. I do a big C, so a capital letter C as in cat, and they're labeled 1, 2, 3, 4 as I go around the Cartesian plane. Here's an example of a cubic function that starts down here in quadrant 3 and goes up to quadrant 1. I just read it like I'm reading a book from left to right, starting here, ending here. Something like this parabola. These arrowheads mean these continue and continue. Even though this, as it's drawn, is completely contained in quadrant 4, the arrow implies that it keeps going past the y-axis here. So this quadratic would actually start way over here in quadrant 3 and end in quadrant 4. So be careful about arrows. Now let's look at some of the similarities that we have with even functions. And when I'm talking about that, I'm talking about the degree. So an x squared function, a quadratic, an x to the 4, x to the 6, 8. If your biggest exponent is even, they will follow this general pattern. So here we have a function, just plain old x squared, and let's take a look at some of the stuff that we know from quadratics. In expanded form, it's going to look like this, ax squared plus bx plus c. The a is the leading coefficient. If a is greater than 0, or another way to say that a is positive, you have a parabola that opens up. It could be up here, it could be down a bit. As long as it's got a positive leading coefficient, it opens up. So all parabolas with a positive leading coefficient are going to have end behavior of quadrant 2 to quadrant 1. Their vertex is going to be a minimum if they open up. Here's the opposite. A is negative. They have a maximum, open down, and have end behavior quadrant 3 to quadrant 4. If we make that bigger but still even, so x to the 4, if we have a degree 4, it's still going to have this same general setup. It's just going to have more terms, and the biggest one being x to the 4. So if we look at a, meaning the leading coefficient of an x to the 4 function, as being positive, it's still going to be like a parabola, how it goes from quadrant 2 to 1 and opens upward, but it's going to have another loop-de-loo in the bottom here, another bumpity bump thing. So if that's happening, then you have a bigger even exponent. So here you can see I've put some other terminology on here. Since these points, like this one here, this is not the maximum on the graph because these keep going up forever. We call things that look like something you could calculate on your calculator as a maximum, but aren't actually the highest point, relative maximum. This would be a relative minimum, and this one down here, this is actually the lowest that this graph goes, so this is your absolute minimum. You can see it's still got the same behavior as a quadratic up here with leading coefficient positive, but it has an extra loop-de-loop thing in the bottom. Here's an example of a negative coefficient. Essentially, this graph here has been flipped vertically. Now it goes from quadrant 3 to quadrant 4, and instead of a quadratic having one vertex here, it has a couple different loop-de-loops in the middle. What about odd functions? So the first odd function we studied in grade 10 was degree 1, a linear function. There's only two possibilities with linear functions. They either go across like this, quadrant 3 to 1, or they slope down negatively, quadrant 2 to 4. The same thing is going to be true of other odd functions like x cubed, cubic functions, or x to the 5. They are still only going to slope crossways, one of these two ways. And when you've got a cubic, it's got a little bit of a flattening or a bump in the middle. It's still going across like a linear function, but it's not completely straight. Okay? This kind of slope with linear was always a positive, and this was a negative. The way I remember it is when I'm reading a book, I read from left to right, and if my line goes up, that's positive slope. If it goes down, that's negative slope. What the slope actually was in grade 10, but we didn't use this terminology, was the leading coefficient. So we can expand on that and say if the leading coefficient is positive, a cubic function will go up like that. If the leading coefficient is negative, it will go down, just like a negative slope would slope down. If you make these degrees bigger but still odd, you just get more business happening here in the middle. More little loop-de-loos or bumpity bumps or whatever you want to call them in the middle. But they still have that general shape of going quadrant 3 to 1 with a positive leading coefficient or quadrant 2 to 4 with a negative. So what I have posted on the website for you is a worksheet that can open up I hope on most devices it's a PDF. So as long as you've downloaded something to view PDFs, you should be able to open it on your phone, Chromebook, laptop, whatever, and some textbook questions to do. If you don't have a textbook and you need an online version, I have that. Reach out to me and let me know, and I can get that for you. If you have any questions at all, I really want to help you guys with this material. Please contact me, ask me questions, set up a time to video chat. I got lots of replies last week from students checking in, and it made my day to see your faces. I'm sitting in my classroom right now, and it's completely empty and extremely lonely, and I'm a teacher because I like kids. So please contact me. I would love to hear how things are going and help you with your math. And if there's any questions, even if it's not math related, please let me know. I would love to help you.